O glorious AD. Oh, and yes, the pink box. Thou must occupy thine pink box.
Stand in the pink box. Well, this one's almost at a reasonable height. So first off, sorry everyone for all the drama with the unique prefix document. I stopped publication for it, or paused publication, because there was an assertion that it was a process violation and that this should have all happened in 6-man. Seeing as the meeting was starting soon, I decided I'd stick it on hold, chat with people and Suresh. Thanks everyone for commenting. It's fairly clear that this was not a protocol change. Before, when it went through initial ISG eval, the document was right on the edge of informational versus BCP. And actually earlier versions of the documents were marked informational. After chatting with a bunch of people, including the authors, Suresh as the 6-man AD, and a bunch of other ISG folk, we think that, just moving it forward, but changing the track to be informational, because of the new text, etc., makes sense. Authors seem okay with that. I think that's best. Then we can just, get it out the door. Does anybody have major heartburn about just changing track and getting on with life? Are you looking for the mic or okay?
No heartburn, but I have a question for the room when you're done.
Yep.
Oh, okay, Eric Klein. The question for the room actually is for the vendors in the room. Are there any vendors who are currently or potentially working on implementing this? And would it be possible, either in London or is it Montreal after that, to have an IETF-64 to the host SSID on which to try this?
So speaking, as somebody who wanders around in the NOC, I think that would be something that the NOC would be happy to consider doing, probably as an experiment. But obviously, it would need to be something that's actually implemented and we can turn on.
Right, we need a vendor implementation.
Yeah, so it needs to be an implementation on gear that we actually have, or can borrow, or use, or deploy, or something.
Hey Warren, as somebody who occasionally walks around with the NOC, any idea what SSIDs are active? Oh, hi, Jim.
And approved by the chair.
Oh, yeah. So, any idea which SSIDs are active in this room?
Well, depends by what you mean in this room. The APs in this room, I believe we've turned off the V4 one, so there should be NAT64 and V6 only. However, just over there, there is a non-RF opaque wall.
We had not announced that we were continuing the experiment of no IPv4.
Yes.
That's what I wanted to clarify. Thank you.
And obviously, please use NAT64 and please file trouble tickets, webpage tickets.meeting.ietf.org, and also please include some stats. And yes, okay.
Yeah, I just like to say that some people have seen some issues on 6-man session, and I think this should be mitigated currently. So don't be afraid to try it again. Don't let your 6-man experience spoil the experiment.
Oh, and actually, if you do have issues on the NAT64 network, something that would be worth checking and just noting is if you still have the default route. In earlier times, we had issues with the default route.
That's what I mean. As far as I know, current timers changed, so it should be mitigated. The issue might be there, but it wouldn't be affected.
Yeah, we bumped the RA timers up from 600 seconds to 9,000. So you shouldn't see that problem again, but it's still worth checking.
For the record, I can see NAT64, IETF, IETF-2.4 only, Legacy 100, and NAT64 unencrypted and V6 only. I think I can see all of them.
So yeah, you can see them all. We have APs here, and those are only doing the V6 ones. Unfortunately, there's a meeting in the room next door, and that wall is not RF opaque. And so those ones you're getting bleed through from. You should, please choose the 6.4 ones, sorry, the V6 ones. And you should also get better signal strength with those and better performance, etc.
So the V6 only one or the NAT64 one? Either. Okay. Okay, cool. Okay, Fred, are you around? And You're supposed to hide in that box, but you'll want this. A little better each day. So, yeah. Thank you. Click the right button. Okay, well, wait a second. What's going on? Speak thing.
You just had your.
Well, I'm looking up there.
Yeah, you were displaying earlier.
Yeah, so whatever the deal is.
Let's try unplugging it and plugging it back in. That's your background. That's your background.
Yeah.
Okay.
Is it a virtual screen? You can try it.
Well, I wonder. There's.
Drag it to the right.
Displays.
There you go.
There we go.
Okay. There's hope. Okay. Go for
Okay,
it.
you can start there. So this document is called IPv6 Prefix Delegation for Hosts. Here you've got the history of the draft. There's been 15 versions of it, most of them within the last couple of months because of some intensive list discussion that have clarified some points, and a pointer to the draft at the bottom. So the document very early on discusses what it believes to be a definition for prefix delegation, meaning that the prefix delegation entails a communication of a prefix from a delegating router to a requesting router, a representation of the prefix in the delegating router's routing table, and a control messaging service between the delegating and requesting routers to maintain prefix lifetimes. And the best example we have today of prefix delegation is DHCPv6 prefix delegation, DHCPv6PD. But now this document is considering the case where the requesting router is a host that obtains a delegated prefix for its own internal multi-addressing purposes or to attach a tethered Internet of Things. So case one, classic routing model. The delegating router delegates a prefix P to the requesting router R. And then R can delegate sub-prefixes from P to downstream networks and or assign addresses A sub I taken from prefix P to a downstream interface. So here you see the downstream interface has hosts on it, and each of those hosts is auto-configured an address from the delegated prefix that was advertised by the requesting node. This is the classic routing model. So you may say that this node is a router. It's not a host. But it could be something as simple as a cell phone that has a tethered network behind it. Or it could be a laptop with an internal network of virtual machines that are using the delegated prefix to number that internal network. Case two, what I'm calling the weak-end system model or the weak host model. The delegating router delegates the prefix to the requesting router. The requesting router then assigns addresses from the prefix to an internal virtual interface like a loopback without invoking MLD DAT on the upstream interface. An example is any host with an internal virtual interface on which addresses can be assigned. So here we've got multi-addressing. So you can assign as many addresses as you like to the loopback interface, but you don't have to do DAD or MLD for those addresses on the upstream interface because that prefix has been uniquely delegated to the node for its own internal use. Case three, we're calling the strong-in system or strong host model. Where delegating router D delegates the prefix to the R, but R assigns addresses A sub I to an upstream interface, again without invoking MLD or DAD. And the reason that can happen is because the prefix has been uniquely delegated to the requesting router and has not been advertised to any other nodes on the link. So an example is any host that cannot assign addresses to any other interfaces besides the upstream interface. And that corresponds to what's known as the strawn-in system or strawn host model. So MLD data implications. The host does not use MLD to join the solicited node multicast group and does not perform data over the upstream interface in any of the three cases. And that's acceptable because prefix delegation guarantees that no other node will receive the prefix. Dynamic routing protocol implications. The host can be configured to participate or not participate in a routing protocol over the upstream interface. The nodes that don't participate in routing protocols, they're going to have to send all outbound packets to the delegating router as the default router. But future redirects may inform the host of a better first hop than that delegating router. Additional considerations. IPv6 neighbor discovery implications. The node is going to act as a simple host to send router solicitation messages over the upstream interface, but it's going to have to set the router flag to true in its neighbor advertisement messages because the thing has a prefix that its routing is directing all packets to that host that match the prefix. The node does not send RA messages over the upstream interface because the upstream interface is not an advertising interface. And the delegating router may return a redirect informing the node of a better first hop via the upstream interface. IPv6 implementations, ICMPv6 implementations. Routers will send destination unreachable, no route to destination, and address unreachable messages to remote sources as necessary. Hosts send address unreachable to local sources and port unreachable to remote sources as necessary. But hosts that maintain delegated prefixes per this document observe both the host and router specifications for ICMPv6 in terms of returning ICMP messages. Implications for vendors and operators. Hosts that require prefix delegations act like routers from the standpoint of prefix delegation, but act as hosts from the standpoint of their local applications. But from the network, it all looks the same. The network doesn't care that there's applications internal to that host that are using those addresses. It allows for unlimited multi-addressing in the spirit of 7934. And multi-addressing does not cause any MLD or DAD messaging over the upstream interface. And it opens new possibilities, for example, a different and unique IPv6 address for each of the host's local applications. And the next step, I would like to ask if this could become a V6OPS working group document. Any questions or comments?
So comments?
Yeah, this is a terminology issue. We had this discussion in 6-man. If you read the definition in 8200, it's very clear on what the definition of a host of a router is. If you put other links on it and start forwarding packets to something else, it's a router. So I think you should use that terminology here. I don't have a big opinion on the merits of this, but at least get the terminology right. Don't make new kinds of hosts. It's either a host and it doesn't forward, or it's a router.
Right.
Let me just, so Fred, I backed up to your case too. You have a number of virtual hosts embedded inside this thingy that the prefix was given to. And I think your statement about this, your statement's correct, but it would have been more clear if you had said that it behaves as a router at the upstream interface, but it behaves as a host at A1, A2, A3, and da-da-da-da-da, which I'm sure is what you meant. And in those contexts, he would be using the language exactly the way 6-man says.
Yeah, thanks for the clarification, Fred and Bob.
So I'm sorry, next person at the mic.
Paul Marks, Google. There's an interesting edge case that comes up when you delegate a prefix to a host. And that's the question of whether any of the addresses are reserved. Like, for example, is address 0 considered a subnet anycast address, or is it usable as a general purpose address? Like, it might be worth addressing that in the document.
That's a very good point. I hadn't thought about that, but it's a good point to address.
So, Ole Tra. I have two questions, but not for you, Fred. So the first one is on the value of this document. If someone in the room who's planning on deploying or implementing this could say how much this document matters versus if they were able to just implement it based on RFC 3633 and the other IPv6 RFCs, especially what we described around CPs as well, which have a very similar description of this one. And the other question is to the network operators, enterprise operators, or anyone who deliver V6 service to end hosts, if they have any plans of enabling this and doing PD to the host. So yes, if anyone want to answer those questions from the floor, that would be interesting.
Eric Klein, Google. So my understanding of the document so far, and I haven't read it in detail, is that you said you were asking about DHPv6 prefix delegation or just prefix delegation? Because this document is kind of general about prefix delegation.
Right, but it prescribes PD to a host, and it's sort of, mostly effectively a router because it talks about multiple interfaces and that. Is that does this document add value over what we already have?
I think
But you have to read the document first before you can answer the question.
No, some of the stuff he's already presented in his slides are questions that came up when we did PIOX, right? And some of so I do think there's possibly some value here. And I also think there's value in recognizing that nowadays a host is just a router that is not currently forwarding. I mean, that is really the case.
Lorenzo Cavigli, big plus one to that. I have lost count of the emails that we have wasted debating on whether a host does this or a router does that. Like, my host is a router some or all of the time on some of all of its interfaces. I mean, I think this artificial distinction is essentially, it's just hampering us at this point. Like, there really is no point in maintaining the distinction between a router and a host. Unfortunately, it's in 8200, which is full standard these days, and I don't know if there's any appetite to change that. Maybe we can do something and saying, look, if you're doing a host implementation and sometimes you're a host and sometimes you're a router, these are the things that you need to do. Now, this document could be some of that in the sense that it tells you kind of what to do. What I don't like about this document is that it tells you what to do, but it doesn't say why. And so I think there is value in a document like this, but most of that value hasn't been written yet. So what I want to know is, I've got this thing that sometimes a host, sometimes a router, it does this, it does that. When you say you don't do MLD on your northbound interface, okay, I want to know why. I want the document to say why, so that when something appears that's a little bit different to what I have today, because today I do 3G and I do Wi-Fi or Ethernet, right? And those are kind of defined, and on those links we know what to do, and your guidance says what to do on those links. But I think we need more of a guidance on why to do things, so that when new things appear, we actually know what to do in the future. So, yeah, like I said, there's a lot of do this, but not a lot of why you should do this.
Very good point. Thank you.
Alex Petrescu. So I have several comments and questions, but maybe some of them I could put on the email list. One of the question is whether in this mechanism, this delegating router could send a prefix to the host, and host could use it to configure a IP address on its egress interface.
Right. That was case 3.
It is possible.
Yeah.
Okay. The second is with respect to the laptop model and virtual machines. I saw in an earlier slide. Yeah. So you have example 1, example 2. Looks like they are distinct, but I may suggest separately that most cell phones, smartphones today, do have virtual machines, even though they are rarely seen, but their modems often are mini VM virtual machines. And whether they have an IP address or not, that's another question, but it's virtual machines on smartphones.
Okay.
And finally, with respect to the operator question that would implement this, or this was raised earlier. This is a very relevant question. I think there may be some operators that would be able to and would be interested to run DHCPv6 first and then DHCPv6 prefix delegation second. But there are problems with this, and the problems and issues are not at the operator, are at the hardware manufacturers. In particular, I could name them, but router equipment manufacturer, modem manufacturers. These are some of the key players that allow or not allow for DHCPv6 altogether. So that were the comments.
Okay, thank you.
Dave Taylor. So my comment is on the very last slide. So I just wanted to say more about the EG, that one, thank you.
Okay.
The EG, a different and unique IPv6 address for each of the host local applications, is the one I want to comment on. I think this is true, and I wanted to comment on that part, because there's actually at least two different use cases I can think of for that, and this is good for one of them and not good for the other. Well, it doesn't work for the other one, right? But that doesn't. So let me go back in time in the 6-man working group a number of years ago when the privacy addresses RFC or draft was first being discussed, and this notion of I'd like to have a different IPv6 address for each of my host local applications actually came up and was discussed at length. And the reason it didn't come into the document, right, it was not precluded in the document, but it was not put into the document, was because if you have a whole bunch of IP addresses, you got to do join a solicited node multicast group for each one, you blow the card into promiscuous mode, and then all of your performance goes away. This does not have that problem, okay, which Fred pointed out. Okay, so this solves that because you're not joining the solicited node multicast addresses, right? So the example that Fred gave is, if it's on your loopback interface, right, then there's no interface that you're joining the multicast node, the multicast address on, and you don't have the problems that were talked about as to why it was not in the privacy document. So that said, there's at least two use cases I can think of that you might say, I'd like a different IPv6 address for each application. One is so that you can use a privacy address. This doesn't help with that, right? Because the purpose of privacy is to prevent correlation, and it's the prefix that you get that's correlated everything, right? So it doesn't, you wouldn't actually use this for privacy addresses because it doesn't actually give you privacy. There are other things that you might use that for, to say I want a different unique IP address for each of the host local applications. So for example, if you were using CGAs or something and use it for cryptographic security purposes, this would work perfectly fine. I don't know if anybody's doing that, but this is useful for that situation. I don't think it's useful for privacy, but I think Fred is absolutely correct that this does not have the scalability problems that the 6-man working group discussed a long time ago. So thank you.
Okay, thanks.
Michael Abrams. So first of all, I think I just want to say that I think this is useful. I'd like to see a document that stitches multiple things together and presents like, okay, here's an end-to-end solution that solves this problem, and it takes these and that and those mechanisms together. So I think there's value in this document. Since this is V6OPS and I've seen this problem live, if you get a delegated prefix and you do stuff to it and you don't black hole route the entire prefix, you might ping pong the packets. This could be pointed out in this document as a concern.
Right, that's a good point. I do touch on the point that the route that the host is supposed to send destination unreachable if it gets packets for an address that's not configured. But black holing the prefix, I'm not sure if I say it in the document, but it's implied and it should be in there if it's not.
Yeah, I think because I have seen actual operating systems in volume that we have that did request prefix delegation when you said to turn on internet connection sharing. I guess people can figure what it was, and it didn't black hole the entire prefix. So you got, it would request like a /56 to configure /64, and then it would ping pong the other ones.
Right.
So it would be good if that was pointed out here as well.
Okay.
Thank you.
Fred, I skimmed the graph, but I don't think I saw this in there. But I'm not sure if it is or if it isn't. How much of this applies to IPv6 prefix per host, and what are the differences between a delegated model and an IPv6 prefix per host model as documented in the thing that's currently in Auth 48?
Yeah, I touched on that one the earlier slide. Let me go back to that. So
sorry, then don't repeat it. I'll look at the slides.
Oh, okay.
Don't worry about it. Thanks.
Okay, thank you.
Well, okay, so I've got a couple of questions, if you don't mind. I'm looking at your case one, and I mean the cases are all the same if we decide to not distinguish between virtual and physical. But okay, so I'm using that one. On the upstream link or on the upstream interface, where is the address coming from that is used by this node? Is it from the subnet that the delegating router is using, or is it from the prefix that was delegated to the downstream router?
It's the prefix that delegated to the downstream router. So on the upstream link, that node is going to have a link local address, and it used the link local address to do the prefix delegation exchange in the first place. But once the prefix delegation comes, that's the prefix that's used internally by that node, by the host/router.
Okay, so now that's different than most routers that we deploy. The address on the upstream interface is in the subnet that the router on that subnet is in. No?
No, I mean, if you look at 7T84, the CE router RFC, it allows for both models. There's ISPs that deploy unnumbered northbound interfaces with just link local, and there's ISPs that use Slack and AutoConf on the upstream link. There are ISPs that only do AIA and A on the upstream. So you'll see a variety of models.
Okay.
In the real world. I don't know about this.
But I mean, if the question was, does it come out of the delegated prefix or not, then no, it does not come out of the delegated prefix. No, it cannot. It can be excluded from the delegated prefix, but then it's not part of it.
There is a requirement in 7084 that says if you don't have NA or Slack on a northbound interface, you must pick an address out of your prefix. That's what it says, right? It's no. Okay.
Look it up.
Right. It says 7084 talks about the virtual interface. That's for internally routing stuff, so it won't actually show up on the WAN interface. So it has to do, it's something slightly different than what it's basically unnumbered at that point. So it's either unnumbered, IANA, or Slack based. They don't ever take it out of the prefix and use it for addressing things coming up the WAN.
I suppose it's a technicality, but like my observation is if you have an unnumbered and you originate a packet, you will pick an address from the delegated prefix as the source address of that packet. And so whether you argue that it is or it isn't configured on the upstream interface, basically only has implications for a neighbor discovery, right? And I think that's even an implementation choice.
So Ole Trond, since I was the one who put the restriction in place in 2003, I've forgotten why, but no, it is because of ND, right? There's no expectation that the upstream router can do address resolution for addresses within the delegated prefix. That is the sole reason why that restriction is in place.
Yeah.
Okay, so the route table in the delegating router, as it's called in this picture, the route table there uses the link local address as the next hop. Okay. Okay. Okay, so before you run away, I think I heard two things. You would like this to be taken as a working group draft. Lorenzo says that if it's taken for a working group draft, he wants to make it an order of magnitude more text. Close? And so Lorenzo and anybody else can volunteer, but I think you're kind of volunteering yourself. If we want to turn this into an architectural spec, would you be willing to help do that?
I think in practice, if I volunteered, I would only succeed in dragging down the document and never getting it published due to lack of time. So I'm not going to volunteer here.
Okay.
I don't know but I'm pretty sure Fred can come up with some rationale for the things that you've written, because he did, the things that it says right now do make sense. You just need to say why they make sense. And once you've written some text, we can all sort of like attack it and pick it apart and be.
We're good at that.
Yeah. So the only thing is like we have this like blank slate that we need to put some text in. No. I think it's like you've got like must do this, should do this, and then you would put about the same amount of text just before that saying, here are the reasons why, or just after that. So, yeah.
Bullet Turan again. So if we're going to adopt this document, I'd really have liked to have my second question answered. Are there any operators who are going to deploy this model? Because I have asked with my IT department, and they just refused point blank, and I asked them a few times because I need this for VMs, for example. And it's let's see if we get some operational input here. Are this really going to be the models that people are going to deploy towards hosts? Or is this not for enterprise? Is it for your public Wi-Fi's, Michael, since you're getting out?
So I'd like to answer that question a little bit. So,
Are you an operator?
Yeah, I'm everything. Like my company does everything. So yeah, yes. So if you think about this a little bit more broadly, I think we should couch this as, what do you do when you have a dedicated prefix to you? Now, if you think that the word delegated means prefix delegation, then that's one thing. There's not a lot of those. There's a bunch of CE routers that do this. But if you think about a prefix that's given to you on just on a 3GPP network, that's basically the same thing. It's a dedicated prefix. And from the perspective of the kernel on one of these devices, it actually looks like a broadcast interface because that's easier to implement. And so a lot of this guidance slots straight into those things, right? Like absolutely, you take this and you put it there because our RMNet interface is really, they have linked local addresses. So I think the guidance will be useful. And so you think about prefix per host as well. And I would not use your IT department as a model for anything, given that they're DHCP6 only, which is not recommended by the IETF. So they're not even part of the conversation here. You were there. It's a product of IETF consensus, just because it has my name on it. So I think I would love to have conversation with the security people in your IT department as to whether V6 prefix per host helps do what they do. Right? And I would also, if somebody wants to implement PD, there is no host support for it right now, right? But that could change.
Ole, with respect to the question of operator, I don't work for an operator, but the question could be very easily returned to a router manufacturer. Okay, is there any router manufacturer that is ready to do some tweaks on DHCP such that to make it work on a 3GPP network? That's the question.
Sure, we would be happy to if the 3GPP guys could do routing.
Yeah, well, they do use routers from particular router manufacturers, but these routers have really sometimes big problems with DHCP-V6. And for example, I could cite a few of them. Some of these routers cannot be configured to accept requests on non-standard ports. Some of these routers use only globally unique address in source packets instead of link local address of DHCP-V6. And it's really hard to make them, and it's expensive also, because somebody said value, I forgot. But it's really expensive. Much money is requested to make small modifications in key parts of the router manufacturer software.
So I'd like to leave vendors out of this. Let's talk about the draft. That's what's on the agenda.
This is where operators raise issues with vendors. Okay, it's not an operator problem.
I should also say that I'm doing this currently on an Android platform with a VPN interface. So I'm doing prefix delegation and assigning addresses to the VPN interface in an Android host.
So this may be answering the question from Lorenzo about the VPN, the why do you write this? And if this is over VPN,
yeah,
then it's completely another.
Well, it's an interface like
does
any
not
other.
depend on operator, does not depend on hardware
Right,
manufacturer.
that makes operator independence, yes.
Michael Abrams. So Windows Vista later does this. I guess you obviously can make Android do this if you want to. We heard at the last session about the Cisco IT guy. He said he wanted to do tracking in the DHCP server, but he wanted to do IANA. He could do PD instead and do the same kind of tracking and run unnumbered on the WAN. And do the same kind of tracking there. I don't know. Do you have Windows? Does he have Windows machine? Does he? I don't know. I think this is a valid model. We have a bunch of stuff that could be made to use this. What you're doing here, and I think it's all a matter of what's default on, what can be turned on, and because right now we have a chicken and egg problem. If there are no devices ever requesting this as they connect, then nobody's going to deploy it. I had the same question about NAT64 V6 only Wi-Fi. Nobody's doing that. Yeah, well, a bunch of operating systems don't work well with it, so nobody's going to do it. So the question is, how we break the catch-22 here? So I don't think that's. I don't think you can answer that. But no, if you're going to deploy this, at least short term.
Eric Klein. I mean, this is the 64 share model right here, right? This is deployed today. If you do V6 tethering on your Android phone, this is exactly what happens, right? There's a couple of addresses pulled on for the device, and the rest of the /64 is shared downstream. I think, and Fred, correct me if I'm wrong, but my reading in your terminology section, delegated prefix uses DHCP v6 delegation as an example of a delegated prefix. But there are also these sort of like implicitly delegated prefixes, like in the 3GPP model and in the /64 per host model. Now, I have not gone through the thesaurus to find a better word than delegated, because it's kind of overloaded with PD and DHCP6 stuff. But right, but the dedicated, sure, but it doesn't have the, yeah. Anyway, yeah, I don't know that there's a better word, but if we could sort of deconflict the terms.
I think I spell out delegated in the terminology. If I don't, I can do it there.
Yeah, you do. That's where you say that DHCP6PD is an example of a delegated prefix.
Right, that was intended.
There's also implicit.
Well, and you derive that term from 36 to 33, right?
Fair enough.
So,
yeah.
Yeah, again, I haven't gone through the thesaurus yet. So maybe it is the best term.
Okay.
Paul Marks again from Google. There was the question of operators using this. We are effectively using this model on Google production servers. So we delegate a prefix to the machines. And I mean, it's effectively static configuration, but it does fit this model.
Okay. Great.
Lorenzo, clearly comment on Alex's statement. It is my personal opinion that you will never get, ever get the HPPD on your Wi-Fi, on your LTE modem until some operator supports it on the server side. You can talk about it here until we're all blue in the face, but the LTE modems are built very tightly to interoperate with carrier networks, which are highly managed networks. They do not typically have a wide range of interoperability with non-carrier devices, right? They are mostly devoted to devices that are very tightly managed, very tightly controlled, and obey very tight carrier requirements. If delegating a prefix to a USB key is not a service that an operator wants to support, no modem vendor will actually implement that, because there's a substantial impedance mismatch with what the kernel knows how to support and how 3GPP actually works. There's really a lot of glue code in there that basically pretends that the PDP context looks like an interface. It's not, right? And so until somebody decides to make it work because some operator says it's going to work because they want it to work, then it's never going to happen, right? I don't, sorry for using strong words here, but we've been talking about this for years, and it's going to be many years before it actually happens, okay? So, but like talking about it here is really not going to make a difference.
Okay. So let me be clear. There is operator that is wishful to work on this direction, okay? There is. That is not a problem. Both ends are there. Operator is ready, and node is ready to do this. the problem is either in the modem or in the hardware implementer to fix protocol issues, but the operator is ready. It's not a prefix length issue, it's not a lack of intention of lack of goodwill. Operator is ready to do this, okay?
Okay, so let's take a hum on that. And I'm not actually talking about this draft as it stands, but with the additional explanatory material that Lorenzo commented on. So turning it into an architectural discussion of that problem. Hum if you're in favor of adopting this as a working group draft. Okay, now hum if you're not in favor of adopting it as a working group draft. Okay, so I heard something very faintly both times. Lee?
Ron, let's check your ears too. So I heard definitely a stronger hum in favor of adopting. I don't know if it's strong enough to call it consensus, but it's hard to see, how many, hums are in the room. So
Yeah. Well, we need to test the consensus on the list.
we'll test the
anyway.
consensus on the list.
So then I will ask the question on the list and we'll see where it goes. Okay, thank you. Jordy?
Okay, I started this work in 2006. We got a lot of inputs at that time, but at a given moment in the working group, it was not considered useful enough. However, I have been running since about 1.5 years ago a survey on how the people is deploying IPv6. And surprisingly, I discovered that 31% of the people who responded to the survey is actually using this. There is also an additional document since 2012, which is the DHCPv6 prefix delegation option to support this. This is the RFC 6603. The problem is that even if this is supported by an option, it's not described in any document. So it's an option for something that it's, let's say, somehow implicitly addressed, but not explicitly documented. Okay. Oops, it's two. Okay. This is some of the stats of this survey that I have been running. At the moment I got responses, this is from 1 month ago, I got responses from 1,513 people in different regions. There is more responses from, for example, from Europe and Latin America, but also APNIC is also responding about that. I have also some pictures here, so you see in which technologies the people is deploying IPv6. There is another picture that shows what prefix size they are providing. And then, as you can see, and I just mentioned about, oops, this is going the other way. 31% of the people is using this technology. There is something that Fred also commented to me, is that we have RFC 6164 that describes using in point-to-point links 1 to 7. But this document is not precluding other options. And this document actually, what it's saying is that routers must support that, but it's not saying that this is the only possible way, or even saying that you should not do something different. And in fact, with the same survey I did, you can see that 62% of the people that is responding to the survey is actually using /64. So there is much more people using /64 than 1 to 7. I think what I'm describing in this document is useful, is something that is actually being deployed more than any other way of doing point-to-point links. It's also simplifying addressing plans in the sense that instead of having two pools of addresses, one for the point-to-point links and one for the customers, you have a single pool. So it also somehow simplifies the troubleshooting, because when you do a trace route, you don't see two different pools of addresses. You see only the pool for the customer, right? In addition to that, in terms of routing, you can aggregate the prefix to the point-to-point links. So I have an example here. If we have the service provider prefix as 2001 DB8/32, and for example, customer A is 2001 DB8/48, the point-to-point link will be the first one, which is in this case the same, but /64. And the provider side can be, for example, ::1/64 or ::1/48. And then the customer side will be ::2, okay? So considerations from DHCP-V6. RFC 3633 is the prefix option for DHCP-V6, which originally avoided it. However, 6603 updated 3633 to allow this option. And then there is another document related, which is 37669, which is in no way conflicting with this. So it's something perfectly valid. In terms of router consideration, this is being used for point-to-point links in both corporate and residential customers. The routers, of course, must support the prefix exclude option, which is 6603. And in fact, RFC 7084, which is basic requirements for IPv6 customer edge routers, already is including the support for this. So if it's being used, it's because it's being supported. But again, the point is it's not explicitly documented elsewhere. I had a clarification from Michael, which is point-to-point in non-broadcast. So I added this text, which is this mechanism will not work in broadcast layer 2 media that relies on neighbor discovery, okay? There is a discussion in the list that may be somehow related to that, to this. It's address resolution to be done only in links which layer 2 addresses. So this is something that probably will go on in the list, and we will see. And I think that's it. Questions, inputs?
Cream pies.
Is this answering, Fred, your question about the conflict that you saw with 1 to 7?
Well, I think the question is what link it's used on. The point-to-point architecture thing that was mentioned, or that I mentioned, was on point-to-point links. And this would be on something that looks amazingly like an Ethernet but connects to an ISP, which is a different link. So, I'm sorry? Oh, so Jordy asked me about my comment about /127 on a link. And the distinction there is that the BCP /127 on a point-to-point link applies to point-to-point links, where this would be on a something that looks amazingly like an Ethernet but connects you to your cable modem or your DSL or whatever in a broadband network. So it is actually a different case. I guess, Lorenzo?
Yeah, Lorenzo Coliti, I was just like, what does this get you over unnumbered? Like, what does it give you over the approach that's written in 7084 right now, which is that you take an IP address from the delegated prefix and you configure it on a virtual interface. Like, what do you want to do this instead? What's the point?
You said from RFC 7084?
Yeah, 7084, yeah. C router RFC. Like, what does this give you on top of the mode in 7084 where you pick an address from the delegated prefix and you configure it. Like, what does this give you?
No. I don't think, maybe I am understanding you incorrectly, but I don't think 7084 says you pick an address, you pick a prefix, and there is the exclude option to indicate the C that it should not use that one.
No. It says, if you don't have Slack or DHCP-v6 on your northbound interface.
Oh, you don't have, okay.
What does this give you over that model? The only thing that I can see that it gives you is that you can basically hang yourself by doing ND and doing ping pong by incorrectly assigning a 64 to an interface that's basically always point to point. Like, the only thing that I can see that it would give you is basically allow you to misconfigure things, but maybe I'm just not seeing it. Like, what does this give you? Does someone have an answer?
There's a question of clarification. Is everything in here already described in 7084?
No, the 7084 is just saying you can use the C router should support the prefix exclude option, but it don't describes what it actually means. So the thing here is we have a document that say you should support prefix exclude option, and then if you go to the prefix exclude option, I think you are actually one of the co-authors, Sole. It don't describes the mechanism, so it's actually assuming that it's described elsewhere, but it's not.
Michael Abramson. So I read the BBF document that recommends two different deployment models. One is a shared /64 with IANA on the WAN, so you have multiple customers where on the WAN they have one IANA, or you use unnumbered, as Lorenzo just said. This basically, if we adopt this as a best common practice, we're basically saying don't do what BBF says. But
I can't even tell what this is telling us.
No, exactly. So, and this is now a BCP. So I think it should have then more justification for its recommendations if we're going down the road. And I think we need more analysis. And basically, we're saying some other large deployments in production right now are not doing this, and then perhaps we should say why that is wrong. I'm not advocating any of these models. I prefer the unnumbered model myself, but if this is BCP and it goes through here, we're basically saying the BBF is recommending the wrong thing.
Well, what I am not sure here is because there are different models, maybe it's not, none of them should be a BCP and it should be all of them informational, but at least we should say somewhere this is possible and people is using it. You know what I mean? So maybe instead of BCP, it must be informational.
I would think it would be great to have a document that goes through the different models and says pros and cons and informational, perhaps. No problem at all. But BCPing this, then I think we need to be pretty sure what we're doing and saying why the other models are bad and we're not recommending them. Informational pros and cons document would be perfect and analyzing all of them.
I think that's not an issue, and I am happy to do that way. Yeah.
I'm not even sure, like, maybe so let's take a step back. What is the problem we're trying to solve here?
The problem we are trying to solve here is this is something that is being done. It's feasible, it's useful, and it's not described elsewhere. And when people is going to deploy IPv6, they may not realize that this is a good way to do that, and we need to document that. Okay, so it's helping people. Hey, you can use 127, and the people is actually reading the 127 as this is the only way, but it's not.
Yeah, so I fully support that. So I like this. This model it works well as well, and I mean this is so having this as having a pros and cons document with all the models. So I do agree. The IETF doesn't list this model in operational documents. I think it is useful to bring this on as an informational analysis of all the different the models that are in use or could be in use or and so on. And I mean, as far as I know, this is compatible with 7084. And as you say, we don't say anything on the architecture part of the addressing on the WAN from the operator side.
So again, what does this give you? It gives you, so pretty much all of these scenarios have a point-to-point connection to the internet. So what's the gain of saying I'm going to number that point to point out of a 64 that I already have? I mean, I just don't see it.
So, Michael Abramson again. So, if you want to preserve TCAM entries on your BCP38 function on your upstream, if you can do this on a /56 level, then you don't need to spend more TCAM entries. That's also a way of doing it. But there are some pros and cons about this. And if an operator today wants to do this, they will most likely BBF document, and it doesn't talk about this. This model is, as far as I know, not in there. I don't attend the BBF. I just happen to read this document from another discussion like a month ago. I would say this useful informational analysis, great.
So, Michael, you will say that instead of talking about just this, I should probably in the document also comment the different models. Yes. Probably in the same document.
Yes, I think there are a number of models in use today, pros and cons, because it could be that there are like 4 or 5 different ways of doing this. You're describing 2 of them. For someone else, this might not be the best model because they have some other considerations. So listing all of them might be good, and I think there are probably 4 or 5 different ways.
I will agree with that, because sometimes having all the possibilities in a single document is very useful instead of the people going to read 10 or 12 documents. So I will agree on that.
Ron Bonica, Juniper Networks, Hatless. I might be repeating what you guys just agreed on. It sounds like an interesting document would be a survey of all the possible numbering strategies you could use, the pros and cons of each. That'd be a good thing. It's just a little bit different from the document we have in front of us today.
Lee Howard, +1 to that. I think that's a better approach. Sort of in response to Lorenzo, I don't know that this is clearly any better than any other model for numbering that link, but I also don't see how it harms anything. And since we know that there's a significant number of deployments doing this, it's one of the things that's useful for V6Ops to do, in my humble opinion, is to document operational practices partly as feedback to the IETF, so that when we go do something else, we know that we're not breaking things that are already in the field.
Well, and our charter says we're supposed to do that. Okay. Details.
So Michael Lorenzo, so what I would recommend is we don't adopt today. We do some more work on bringing out more of the models.
And I'm just trying to figure out what the right summarization of that more work is. Sounds like a survey of practices on the customer-facing link.
Okay, so there are 2 ways I think this can go forward. First of all, we basically say, here's what a bunch of ISPs are doing, and we publish that. Or we say, here's how this model is supposed to work, because that text is not in this draft. It really isn't. It says like, well, if you're doing PD, then you should do this and you should do that, and then like interface should be 64. It doesn't say if you configure and address, here's what you need to do from an ND perspective. It doesn't say any of that. And so, if we want to document a new model, then we have to define what that model looks like. If you want to do that, at least if it's text that we can say, look, if you want to make this work, do this, then, maybe at least it's of some use. Okay. So I'll let you decide how you want to proceed on that. But
well, I guess it's clear that the ideal is, instead of going just with this model, making a new version of the document, probably changing the title or whatever, documenting different models, not just this one. I think that's fine.
Different models and giving the rationale, giving the reason why. So, okay. Don't go too far. You've got...
Yeah, I know.
Okay.
Okay, so history of this document. In IETF 98 in Chicago, the working group accepted RFC 78-bis, and that document included the new transition mechanism plus HNCP, okay? I had, I think, 4 or 5 versions of that document before Prague, but right before Prague there was somehow a pushback from the working group. It was just a couple of people, not let's say the working group is picking up, but we know this is what is happening. Very, very few people actually is active in the list. So in Prague, I presented several choices, and I don't think there was a clear consensus. But then we had an informal talk. Even one of the co-authors of RFC 7084 was in that talk, and somehow we agreed to bring to the list, and I did that to stop the work on changing RFC 7084 and seeking consensus for a, let's call it, complementary document to RFC 7084 only for the transition part. So that means also not including HNCP, okay? Basically, we have the same situation as we described it in the previous two meetings. The actual situation is people still need IPv4 support in the local area networks. I don't think residential networks and even enterprise networks can be like the experiment we are doing right now here. So they still need IPv4 support, and unfortunately, that will be the case for the next 3, 4, 5 years, maybe even more. I wish it's just 2 years, but it will not be like that. So there is no way the ISPs can deliver IPv6 only service in the LANs. It's fine for the ISPs to have the access links, which IPv6 only, but in the LANs, there is still need for supporting IPv4. Everybody has and you can still buy today IPv4 only cameras and devices of all kinds, so we need to support them. So that's the reason for this document, making sure that we have the actual transition mechanism being supported by CIS. Right now, RFC 7084 is only supporting 6RD and DS-Lite, nothing else. So it don't make too much sense. I did in the APNIC in Taichung in September a panel with C vendors. I requested vendors in this list and contacts with many vendors that we had, but unfortunately we only succeed to have 3 of them. So we had D-Link, we have NAC, and we have Sixel. And we were commenting in that panel this situation, okay? I have written an article, you have there the link, and there is also a recording of the panel. So I warned the panelists, take care with what you said because it's being recorded so everybody can see that later. It's 1 hour video. I think it's very interesting for everybody. I talked about some specific issues in the HomeNet session also a couple of days ago. I think it's very relevant as well. Oops, this is going, oh. So, what is the summary of the document? Well, basically, the document didn't have changes in the text from what I have presented in the previous version. It's just excluding the support for HNCP. So the document is talking about supporting 464XLAT, MAP-E, MAP-T, Lightwave 4/6, and of course, the same mechanisms that are already in RFC 7084 and all the RFCs that are required to support those mechanisms. Okay, so here is a list. I am not going to read that. One of the comments I got from Fred and Ron is why in the document I am including the support for 6RD and all that stuff. Well, I am including that just to make it coherent with RFC 7084 because we decided not to change that. So if I take down now those mechanisms and this document is complementary to RFC 7084, it's like a conflicting thing, right? I am happy to change that. I don't need and I don't want to extend IPv4. I just want to make sure that the people get Cs that support IPv4 in their LANs at the moment because that's what they need. But I am not really asking the working group to keep supporting IPv4 at all. I think that's clear. I am not really sure how it works to have this complementary document if we take that out. But that's a different question. Oops, this is going. So basically what I want to make sure here is that the operators can get from the market and also end users from the retail CEs that support this transition mechanism that we need today. And that's it. What I heard from the panel, and if you read the article, I think it's very clear, or if you see the video, is that in general, vendors don't have problems supporting all these mechanisms. In fact, most of them have they already, but they don't deliver in the retail firmware. Okay, so it's the same hardware, but that's being provided only when an operator asks for it. The problem is that, of course, sometimes the customer wants a better router, for example, which better wireless connectivity or whatever, and they cannot replace that because it's not available in the retail firmware. So that's it, I think. Yeah.
Michael Abramson. So you list, for instance, 6RD in there, and there is a bunch of stuff that looks like it's lifted out of 7084. Is it exactly the same, or?
It's exactly the same. I
Okay.
put that at the moment because I am not sure how to do that.
Right.
So I am asking the working group how we should do. We should take it out, and then it's incompatible with existing RFC 7448.
So I see this as somewhat of an inventory of the transition mechanisms that we think or in potentially will be in wide use. So for the 6RD, for instance, I think it's okay if it's in this document, but it should just say look in 7084 for 6RD requirements. Just don't copy paste.
Don't repeat. Okay.
Just
Yeah,
say,
you're right.
Go,
Yeah.
go, just link it there. And the same thing with, I don't know if 16.4 is in that as well, but just point back to 7084 and don't, redo this.
Fine with that. Yeah.
And the other thing is, this is an informational document with a lot of musts and shoulds in capital letters and so on. I don't know, I'm fine with that, but is that the way we normally do things, Fred?
Some people are bigger on that than others.
So it's not really a problem if we decide it's okay. It's up to us.
If we decide it's okay, it's okay.
What I did is follow it the style that we have in RFC 7084, nothing different.
Yes, that's what I thought as well. And
right.
Barbara is going to touch on. We were discussing about the best common practice and propose. I don't know what's the 7084. What? Informational. As informational as well. Okay, so that seems good.
Barbara Stark. Yeah, I did actually very specifically argue for 7084 to be informational. And one of the big reasons is it's really impacted by whatever the networks decide. And so it has no ability, it's a response as opposed to an actual, standard or anything, or even best common practice. It's just, here's what the access architectures are doing, and so here's what you have to do if you're going to connect to them. But one thing I wanted to say was, what I had hoped would happen from this was just leave 7084 alone, and then this document would be about how to provide V4
as a
addressing
service
in a tunneled mode. And so 6RD stays out of it, all that other stuff stays out of it. That stuff's already in 7084. You don't have to mention it, don't have to reference it. Ignore it completely, please.
Okay. One additional thing I didn't mention before, and I think at least one of the panelists from the evening session is here. I got the promise from another one that he will be in the Jabber, if you want to confirm, is they said they are not implementing those mechanisms in the retail firmware because it's not stated in any document. So that's the relevance of this document.
Yeah. Michael Abramson again. Yeah, I really like 7084 as when you're an operator, it's helpful with that guidance to just be able to say, look, we want you to implement all the stuff that was in there for this relevant mechanism. So I think this document has value for the same reasons for the transition mechanisms. So just easier for operators to not forget when they're doing requirements towards operators with that guidance. It's really nice. So yeah, I think it's probably cleaner if we just keep it as Barbara said and take out the V4 WAN access mechanisms and keep it as it is. Because I still think I don't know. I think this is very valuable as an inventory of transition mechanism.
How's you dealing? That wasn't me. Just make sure.
Thank you. I guess the question I have about the document, as much as anything, is that it has the effect of increasing the price of the CPE.
Not really.
Actually, it does. And that is because every line of code costs something. And the more code.
Actually, it has no effect because when a CPE product manager decides what to do, they're going to ignore this document. So because given the choice of increasing their product cost and the choice of not increasing their product cost, they're going to pick the not increasing the product cost option. Mm-hmm. So I personally don't see much value. I think if there were value, it would be around, which of these technologies do you do first? If both of them are available, which one do you pick? That's almost certainly going to be up to the ISP. One thing that's valuable, I think, is like which ones do you choose? How do you determine what's there? Like how long do you wait between figuring out what's there and what's not? Do you try 7050 first? Do you try whatever DHCP? That I think would provide value. Just saying, go implement this. I don't know that anyone's going to do that. I mean, like there's I had a hard battle to fight just to basically say to some implementers. Look, 7084 says you must not drop port 500 inbound. It's like, all right, fine. And so, but it took a while to convince them. But like getting them to write new code and implement new stuff, I mean, that's just beyond the pale. I mean, if they're going to make that choice based on whether that code is going to provide benefit to their customers, I think.
What I heard from the panelists and also talking with other vendors of list, they tell me basically they have implemented it and they are providing it to ISPs, to RFQs, okay? So having it in the firmware for retail, it don't really increase the price. I don't know, maybe Hans want to confirm that, but it's something that is done. We have the same, as you said, for RFC 7084. The people like it or not, but sometimes the people implement what is in documents as a suggestion at least. And I think that's the value of it.
Michael Abrahamson again. So I've pointed people to 7084 50 times in my life at least, just as when they were like, we don't know what's out there. It says what's available, and basically it's a bootstrap. I mean, you always need to customize these things, but it gives you a starting point. And I think it's the same thing here. So this is not going to, I agree with you, this is not going to change what goes into the retail software. But when I'm discussing or someone else is discussing about what transition mechanisms should we choose? Well, here is a document that has a laundry list of what's available. I love those kind of documents because I can just point it to them. They can go away, read up, and then we can continue the discussion. I think just for that and nothing else, this is a valuable document.
How's you dealing? We implement something doesn't because it is being addressed in the RFC or not. We actually have our implementation way before there was 6084 and way before it was like 6204. So we do have those transition mechanisms, just like I mentioned in Epic 44. However, we don't do it in the retail because we don't see it is necessary to be deployed in the retail models.
So I have a question for you.
Hans.
I have a question for you. From a product marketing perspective, what do you see as the requirements for transitions? Do you see people going for native deployment, or do you see people going for different transition mechanisms?
Actually, I have no idea. However, we do RFP, we do RFQs and RFPs, and if we have those from the operators, then we deliver what they want. That is why I say we have those implementations. However, we don't have those implementation being deployed in our retail product because we certainly don't know and don't see how users gonna configure it and how people gonna correctly configure it before without a help or without a support from their operators. And we certainly don't want to increase the loading of our customer service center. So we decided not to put those stuff in the retail routers and keep it as it is for today. And to be very honest, yes, today we support 6RD and DS Lite. However, it was not because these two protocols are addressed in RFC.
Okay, Alon?
Hi, Alan Gerard. I think there are two different issues here. The first one is, do we want a document that says we need to keep supporting IPv4 in some way, shape, or form? And this is something that CE vendors should think about and provide a solution to this. That's one question. And the other is, do we want a document that lists kitchen sink of all the transition mechanisms that are available and says implement them all or implement at least one of them? So I see a lot of value in the first one. On the second one, it seems that it's unclear if we want to recommend to implement them all or simply say pick one.
In the document, I am not recommending one for two reasons. One, because this is the same way as RFC 7084 is doing. And second, because I think each of the transition mechanisms that I am including in the document has its value depending on each specific case.
No, I totally agree with that. The question is, are you asking the CE vendors to implement them all?
Well, one thing that maybe I need to explain here is that all of them are basically the same code. Okay? So if you ask to an implementer, they will tell you, and you can see the source code, for example, for OpenWRT, that basically everything is the same. It's the way you configure the interfaces, but it's not like implementing, let's say, three different things. It's implementing one thing that can be configured in three different ways.
So I agree with you, that's a possibility. Now you're moving the problem to how do you configure it, and what the end user who doesn't understand any of this thing sees. Does he see a list of 5 different things? He has to check one randomly, or is there a mechanism that's
there is a document. I don't remember the document number right now, but there is an RFC which is a DHCP option for choosing which one of them the ISP is using. So there is a DHCP option that can be sent from the ISP to the CE to configure which one.
So essentially, my recommendation to you would be to separate those two discussions. I have one document that says it's really important to have something for V4, and another one that says, okay, this is the list of possibilities, and this is a mechanism that will help you to decide which one to use.
Lee Howard. I've always been a little bit uncomfortable with using IETF documents as product specifications. We've done it several times. I've contributed, probably co-authored documents that do that, and still been a little conflicted about it. And I feel like that's what this is doing. That doesn't mean that I oppose it. It's just, it feels like an odd space for us to be in. RIPE 554, is it? Is pretty much that. There's a RIPE product spec document that has been very useful. So if we don't get consensus here, I'd like to actually see this work continued in another document series someplace else where we can do it. It seems to me that all engineering problems are business problems. And the complicated analysis happening here is that different ISPs are using different transition mechanisms. And so retail CPE, in order to be able to take advantage of those without knowing ahead of time which market they're selling into, may well have to implement all of them. On the other hand, it may be that one transition technology is predominant, or one or two is predominant in a given market, and that a CPE vendor may only be selling into a market where they only need to implement one or two in order for those to be used by that ISP. It's further complicated by the fact that there's no benefit to the CPE vendor directly to supporting that. Maybe they get a sticker from an ISP that says compliant with this ISP's specifications and requirements. But in that case, if they're trying to get the sticker, they don't need this document, they've got the ISP's document. Only if they're going to try and support transition mechanisms in many markets do they need to support all of them. And the trouble there is that, again, there's no, I don't think there's any additional revenue. The benefit to supporting more transition mechanisms is that the ISP gets support for their transition mechanisms. But then you get into the calculus of a customer. Eventually, I would not be surprised if ISPs start saying, if we have to spend more money to give you an IPv4 address because you don't support one of these mechanisms, then we're going to charge you more. And then we get into a conflict between the ISP and the CPE vendor, or the retail market in some way. So that's how, sort of the chain of logic that I follow to get to something has to be supported. And I don't exactly know how to break that deadlock. I'm not convinced that recommending we support all of them is the right answer. I think that does still need to be a market analysis decision by the CPE vendor. It would help if we had more operators saying, here's the mechanism we're going to use. But we know, I think we can name somebody who's using, or at least in early field trials, for every mechanism in the list. So that's, and again, maybe part of what we need is a market analysis saying, just listing ISPs and transition mechanisms in use or announced. And that would help draw, and that alone, definitely not an IETF document, but that alone might actually accomplish the goal that we're trying to do here.
Stephen from Rectan. I realize I'm really new here, so I guess it's really a new perspective or for everything. And so from what I want to say, it's like, I mean, there's of course, there's a lot of valid arguments about the C vendors and also the ISPs and stuff. But from perhaps on the other hand, from the consumer's perspective, it would be really hard for them to understand all of these technologies. We talked about configurations, right? We talk about letting them configure this or that or that. But the problem is it's even harder for them to choose which one to buy to begin with, right? I mean, if I don't know what exactly I want to buy, I mean, which exactly things and which exactly technology that the ISP is going to support, I want to buy a product that has everything so that I could just use it. That actually goes into the other side of that perspective and saying, okay, so but the question is, you're perhaps having the right argument is, do we need a document for that? Or is that basically what the CE vendors has to do on their own research? That's a good question too, but it would be nice to have a guidance. I mean, this document seemingly be informational. It's not really a standard that everyone has to adopt. So I guess it could be a good compromise in some sense. Just thoughts.
Actually, that's what the support for 6RD and DS Lite is doing in RFC 7084. It's not mandating one or the other, but it's suggesting, hey, this is something that you should consider. I think it is the same way.
So let me step in here. Mark, you were on the Meet Echo thing, and you appear to have gone away. Do you want to talk? Question?
You may have lost connectivity.
He may have lost connection. Oh, there he is. Okay, so fine.
To a
Mark?
certain extent, we've got lots of mechanisms. Most of them have got DHCP options that will completely configure the CPE device. I don't see why how a CPE vendor has real problems here. You send out the options, see which ones get actually filled in from the DHCP server and configure the device. It's not that hard. And most of many of them you want to reflect internally on the internal side as well. But that's basically it. I've got a cable modem here. It provides a Ethernet interface. Lots of router vendors, lots of ISPs here. We just put the ISP modem into bridge mode, and we need the router that we get from the store to work with every ISP. Okay.
Okay, thank you. Alon?
Alain Durand again. I think what Lee said and what Mark just said really argued toward having a simple document versus you need to have IPv4 support and then start another piece of work, another body of work, maybe along the line of what Mark said, to try to figure out how to help the CE vendors to navigate through the mess that we have created of having way too many mechanisms. So in order to get something out now, we write a document that simply says you need to make sure that there's some form of V4.
Ian Farrer. Next point, one of the things that I see as an operator and evaluator of potential CPE devices for purchase is that from vendors we get a kind of divide and overcharge approach from them. So they'll look at this one particular thing and say, oh, that's special. No one's ever asked for us for that ever before. Therefore, that's going to be an expensive thing. And from what I see in the industry overall and my knowledge of how these things are implemented, I know it's the same code base and I know what they're trying to do. So I'm not sure if this is the right document to do it in, but it's having some kind of acknowledgement that, we've got a very similar data plane. These are variants of the same thing, is a useful thing to have written down somewhere. I think there's also some value in the introduction to this to have some text in here to say, there's a number of different things out here. We're not recommending any specific one of these. But if you do want to support this, these are the things that you should support to give a full implementation, a useful implementation a vendor can use, an operator can use.
In the document, I have an introduction section that explains the problem. This gives me back to the suggestion from Alan to split it in two documents. I think actually it's more useful to have it in a single document. So the introduction that probably needs to be updated with some of the inputs from here today, but I think there is a very, very clear explanation already in the document why we need IPv4 as a service, and then here are the options. I think that's the thing. I'm not sure if you will agree with that.
Well, I mean, the idea here was really to have some text that recognizes that, there's a number of different things here. We're not recommending, mandating, or any one of these, just saying, if you wish to implement this particular function, these are the requirements for that function.
Okay, so basically what I believe I am missing from what you said is stating clearly that we are not recommending one or the other. We just describe how to implement each one.
I don't think you even need to say a recommendation, because the document doesn't make any recommendations in there, but just text saying that there are a number out here. These are the requirements.
These are the options, and these are the requirements for each one.
No,
okay.
I mean,
okay, I'm capping the mic.
I mean, to my first point, I'm thinking further about that. Whether it's worth saying in here that the data plane is common and there is reusable code. I don't know if that's something that should go in here, but it might be worth having some kind of indication of that.
It's also in my document somehow. I will need to update it, but it's in my document as well. Okay. I think it's at the end in an annex.
Okay, thanks.
Okay, Lorenzo?
Just responding to what Jordi said, on document there's a lot of should in there, and I think maybe we should remove them. This ability, if you want to go the way you're suggesting, you should point to the other document and says everything is explained in those documents, and not add additional requirement or additional should to what documents are already saying.
Okay, let me explain that very quickly. What I am doing again is following the same scheme that RFC 7084 is doing. So what is being done then for the documents for each transition mechanism is, if you want to support this, you should. You understand that? So I am not saying you should support everything like that. It's if you want to do map, you should this. So I am not saying.
Well, if you want to do map, you should read the map document.
Exactly. Well, but
I think that's one of the points.
Sometimes there are some additional
Am I
things
correct
to
on that
consider.
alone?
Yes, right. That's what I'm saying. If you want to do map, go read the map document, period.
Well, why did we do 7084 at all? Like, I don't agree at all. I mean, in all these documents, there are several ways to do things.
Yeah.
This is recommended a few different ways. Say, if you implement this, you should do this, and that. And those documents might say you can do this or that, but this document is not recommending that. It's only recommending this.
Lorenzo Colli, I wanted to maybe start off with responding to something that Mark said. Most of these things have DHPV6 options. I want to say that I feel physically safe, separated by thousands of miles, when I say that 464XLAT doesn't have a DHP option. It uses 7050 DNS64 as a provisioning mechanism. I only feel safe because I'm separated by thousands of miles in saying that. But so it's a bit of trolling if you want. But I did want to get back on what Mark said and what Ian said, which is Mark is saying, well, the ISP has the opportunity to control all this stuff by using DHCP options. And Ian said, we just get charged 5 times for the same code. Stop it already. One thing I wanted to observe about that is if we have a document that says, here are the rules of the game, try this first, try that first, prefer this, prefer that, then what you can do is you can avoid divide and conquer by implementing all of the mechanisms. And then you say, hey, CPA vendor, if you implement at least one of these, you're not going to charge me twice because you already have it. And we support it on the network side. Okay, but then you have a business negotiation. But I wanted to observe that this is a possibility that you can have, right? You can, if we have a document that says, do these in this order or do these based on these policies, then you can try to like overcharge each other or not overcharge each other, and you don't have a stalemate. That's all. And so one thing that might be of value here is to say, look, if you have this, do this, otherwise do that, and provide essentially a provisioning order or something. Because if you support map, then do map is not useful text. I agree with Ellen, right?
Lee Howard, especially something that Lorenzo said was, I think, a good point that I had come up to ask, among other things, that I didn't understand the point about about lack of clarity on how to decide which mechanism to provision, because you get a DHCP option, and if you get options telling you to provision multiple mechanisms, then you have a failure, and it doesn't matter how many you've implemented or not implemented, yet somebody's done it wrong. If we wanted to create a new scenario that said step through various ones, hey, thanks everybody, this is great for my business. But in particular, but you're right, Lorenzo, that DNS64 and 464XLAT aren't exactly DHCP provisioned. So that's a different case. I think there is potential logic there, where to say if you don't get a provisioning option for one of the other mechanisms, hey, maybe you want to try, and you only have V6 availability, maybe you want to try CLAT. I could see writing that logic. That would make some sense to me. I'm a little uncomfortable with making a statement that of the form, we must support IPv4. Last time I did an analysis, it looked to me, I tweeted a couple months ago that in 4 years, 80% of the world will have IPv6. That's getting pretty close. And I don't want to say, the lifetime of an RFC is forever. We can deprecate later, but that's just maintenance that we need to do. saying, here are mechanisms and here's how you can do this. I do think that, obviously, my business, I think that transition mechanisms are necessary for some time, but I don't want to say that IPv4 is forever.
Okay, now with that, if I'm going to draw any consensus out of the discussion that we just had, the consensus I would draw is that each of us has an opinion. Anybody want to argue with me on that one?
I have 2 opinions.
You have 2 opinions, okay. Okay, so I don't think we've come to anything conclusive on this particular document. You have one additional document that we haven't gotten to. And so I'd like you to move ahead to that one.
Yep. Okay. I started working in this document after we have, I think it was in Prague, a discussion of using NAT64 as the default IETF network as we are doing right now here. I was suggesting why not using 464XLAT instead, because we know, and it has been confirmed this week here, that some applications still break in the NAT64 network. Then we had the discussion about if we need to support 464XLAT, which or without DNS64, because it breaks DNSSEC. Of course, 464XLAT can be used with or without DNS64, which is not possible with NAT64, because NAT64 mandatorily needs DNS64. On the other way around, 464XLAT mainly has been deployed up to now in cellular networks. But if you count the number of users that 464XLAT, it's much more, probably in hundreds of millions of users than all the other transition mechanisms together, okay? And what happens most of the time is that operators for non-cellular networks don't know that 464XLAT is also useful in those cases. Right now, there is some initial deployment of 464XLAT in non-cellular networks, and I see the case for documenting that, and I think a lot of people is missing that possibility, especially when they have bought a cellular and non-cellular network. It makes a lot of sense to have a single transition mechanism. So this will be the case I am just describing, an operator having bought a cellular and non-cellular networks. And the point here is to describe, and I believe it's a BCP, that we can do that, okay? Again, it's same question as and in the previous document, the first one I presented today. I am not sure if the BCP status is the way, but I really believe that it's probably the best, especially considering that 464XLAT today is not a standard compared to the other transition mechanisms. So this is a way to tackle bot situations, describing the actual deployment and also making 464XLAT somehow at the same level as the rest of the transition mechanisms. To deploy 464XLAT, you need to follow about 10 documents. So I think documenting in a single document, it will be also very useful for people that really want to go to that. Instead of trying to find all the documents related to that, they have a single place to read all what they need to do. Basically, the thing is deploying IPv6 as a service. So as I described it in the previous presentation, we like it or not, but we will need to provide still IPv4 as a service in the local area networks for at least residential customers, but also many enterprise networks for a few years from now. Okay, what I am doing in the document is looking at DNSSEC considerations. So there are different ways to deploy 464XLAT to avoid breaking DNSSEC. I describe also how to deploy 464XLAT and the pros and cons with and without DNS64. And there are other sections in the document. The document is a lot about DNS64 because it's part of the problem, okay? If you want to deploy 464X-LAT. This is not typically a problem in cellular networks because typically it's not being used DNSSEC on the smartphones, but we are forgetting that the smartphones can be used as with tethering, so other devices behind can be used can use DNSSEC. So I think it's also useful for those kinds of networks, not just for non-cellular networks. So the document is not targeted to cellular or non-cellular; it's targeted to any 464X-LAT deployment. And I think that's it basically.
Lorenzo Cuddy, I don't think the Apple engineers are in the room, but they will tell you that they will probably tell you that they'll never implement 464X-LAT. And the truth is, you don't even need, this is not even about 464X-LAT. What you're saying is you can do, I think what you're saying is you can do NAT64, DNS64 on a non-cellular network. That's certainly a useful thing to say. We support it. For example, Android supports it. I think there's value in stating certain things about that. For example, that, what do you do about neighbor discovery of the address that you need? I disagree, for one, with the assertion that you need a dedicated 64 for the CLAT prefix. We don't implement it. I don't think it's necessary. There's already 2 nets in the path. I don't care if you add a third one. On the other hand, the DNSSEC issues are things that we do need to document. We need to slug through those. And we need to say, you'll have to come to peace with Mark Andrews and on how to figure out how to do this safely in terms of DNSSEC. It's true that you could, if you have a CLAT implementation that's line rate, which we don't have, at least not in stock Android, you could send all the traffic through 464X-LAT. And some operators do want to do this. It's not clear to me what you can do on an Apple-style approach where you never use CLAT and you always rely on basically V6 only apps. So if I were to summarize that, I would not make this about 464X-LAT. I would make this a document about how to provide service on a NAT64 DNS64 network. I think really from a host perspective, I think. Forget about 464X-LAT. 464X-LAT is one way you can do this. You can also say the apps can't support v4, and that's it, which is what Apple does. So support that as well, and then see where you land.
The difference, Lorenzo, I think the difference is if we do that for just NAT64, you mandatorily need DNS64, while in 464X-LAT, we can agree maybe that we should recommend not using never DNS64 for CLAT. Maybe, I don't know. I am just asking.
I mean, Mark was saying on the list, I think, he said, look, all you need to do is to stub out IPv4 only.arpa. And basically that's the only, I think what he said is that that's the only name you need to do DNS64 for, and that's fine, right? I mean, you can do that, right? That solves that problem? Yeah. There he is.
Mark Andrews.
Yeah, that's what I was saying. IPv4 only.arpa is the only zone you really need to have there, because that gives you all the information to create the mappings. The DNS64 document itself really needs to be rewritten too. But I don't know whether we want to revive Behave or do it here or somewhere, but it's seriously wrong.
So Mark, can you just stay on? Oh, no, he can't, possibly. There he comes, yeah. Why can't Mark just be there? He's the only one talking anyway. Can't we just have him here? Thanks. Ole Tran. So I think you're really muddling up your terms, which makes this a confusing read and a confusing discussion. 464XLAT is stateless or stateful NAT46, typically stateful, unfortunately. You haven't even implemented stateless? Jesus Christ. And a stateful NAT64 in a network. That is 464XLAT. And sure, you can use that NAT64 for other purposes, and you can let IPv6 only applications use that NAT64 to reach the legacy v4 internet. That doesn't mean that that's part of 464XLAT. So the DNS64 discussion is about NAT64. It's exactly the same discussion we're having here on the IETF network. And you should not muddle them together. 464XLAT is just a v4 tunnel with zero NCAP. Like we have 15 other mechanisms doing that. Those do not have DNS problems. NAT64 do really have DNS problems. And I agree with Mark, we should solve them. I sort of thought the discussion we had on the list sort of petered out saying, well, you shouldn't have DNS64. You should let the host synthesize addresses itself. Then you have no dependence in which DNS recursive resolver you need to use. I can use DNS over TLS experiments, and I could still sit on the NAT64 network, right? But this is, yeah, it's been troubling. I think Mark said this had been difficult for 4 years, and I guess it's, it'll probably be difficult until v4 has gone away.
In terms of doing wireline, getting lovely feedback. Sorry. I'll just take the headphones out for a second. And NAT64 can support MAP-T. I don't see why we should be encouraging the wireline to go to NAT6 to go 464XLAT when you can use the same NAT64 to support MAP-T.
I think the point here is because 464XLAT, as I already mentioned, is the most successful transition mechanism.
That's not true. The NAT64 is the most successful transition mechanism.
Well, the combination of both.
Usage of NAT64, DNS64 is split between implementations to do 464XLAT and implementations that tell the apps you can't have a v4 address ever. Okay, so what I think we need to do, and to answer your question, Mark, I think why are we doing DNS64, NAT64? I think let me see if I can identify something of value here. I think it's of value to say there are there's wide deployment of host implementations that can survive in one of two ways on a NAT64, DNS64 network. All of those hosts either don't support DHPV6 at all or don't support the DHPV6 option to figure out what the map server is, right? And I don't see that happening. But fortunately, that type of provisioning isn't necessary. So what we could say is there is a solution with widespread host support in whichever way that allows hosts to work on a NAT64, DNS64 network. Now, the thing that we need to figure out from there is how do we do this without breaking DNSSEC? And I think that's an important discussion. And then we need to get away from 464XLAT as being in this document. So what I would suggest is make this document about how to do NAT64, DNS64 without breaking DNSSEC on hosts. And I think probably there's a lot of that already in this draft. And I think that's actually valuable.
Jerlinkov, I just like to comment on why we are doing NAT64, because there is a use case. In some cases, you do not want to have IPv4 address on an end host. All other transition technologies still like dual stack light and other stuff still requires you to have IPv4 address on a host. And then you can have some part of your infrastructure being V6 only. So I think NAT64 is currently the only way I can have V6 only host in the network without changing everything on the host and requiring doing some tricky stuff. And from my experience, most things just work on NAT64. Yeah, there is like some percentage of broken thing. Yeah, like DNSSEC, and I agree with Lorenzo, we need to figure out how to do that. And measurement I did 2 years ago showed that signed names without quad area record was 1.7%. So it's not like huge number, right? And I probably need to do it again and see if it's decreasing or increasing. Because it would be, because again, we're trying to solve problem for other people who, for some reason, like DNSSEC but do not want to do V6. And again, I see it's my action item. I need to check the numbers again. Yeah, but it's not such a like huge issue, and I'm strongly against putting too much pressure on a host, which normally works.
Where I'm sitting here on the network, I'm here. If I didn't tunnel IPv6, I would have only IPv4. My ISP doesn't offer me IPv6. I can turn on DNSSEC, and it does support DNSSEC. They validate. Their recursive servers validate. I can use it internally. We have it trying to get both going at the same time is difficult. At the moment, we've created a situation where you can't deploy DNSSEC unless you've already also deploying IPv4. And that's deploying IPv6. And that really is something we shouldn't have come to. And as for the percentages, ask Google about what numbers they needed for in terms of failure rates before they were deploying IPv6. It was much lower than the 1%.
Yes.
Okay. 冲锋, Xie of China Telecom. I have 2 comments about the scope of this document. Firstly, is about the scenario. It seems that X-late NAC technology is unlikely to be used in fixed IP network in short term. It is possible to be widely used in mobile network. So my suggestion is whether you need to narrow scope this document when you focus on mobile cellular network. The second one is that right now, as far as we know that mobile network serve not only X-Late supported Android system, but also supported some other, such as iPhone device. So some of them support X-Late, some may not support X-Late. So from the perspective of operators, maybe it is too narrow to define how to deploy X-Late in our network. We need to cover all the devices. So maybe it is better to change the name to NAT64 deployment to serve all the kind of devices. That's my suggestion.
2 comments. For the second point you raised, I talked with David from Apple a couple of days ago, and he told me that they are implementing CLAT. Okay, so that means that iPhone will support also. That's what I understood. I think Lee was with Smith.
I overheard that conversation, and they said they might support it for tethering.
Okay, then I misunderstood that. But for me, it was clear that they are going to support it. And the other point is why you think that 464X LAT is not going to be deployed in non-wireless networks, in non-cellular networks. Sorry.
I mean, maybe it is possible to deploy only in cellular networks, because the broadband fixed network will serve a variety of customer, different types of customer. Yes, so DualStack may be the mainstream in the short term. We serve not only household users, we also need to serve enterprise customer. So IPv4 may be using.
I don't agree with that, because what I am doing with customers, especially in Latin America and Central America, is actually they don't have addresses and they really need to deploy IPv6 only access networks to broadband customers, and this is the way they are doing. I have right now 3 trials with 10,000 customers among these 3 trials using 464 XLAT.
Okay, so we can talk this offline.
Yeah.
Okay, so seeing that the mic line has depleted, I think we're not ready to ask for adoption on this. What would be useful would be for you to come back with a document that's responsive to the discussion we just
I
had.
think, if I captured correctly, I think what I heard basically is that people believe that a document like this will be useful, but not just for 464 XLAT, but for documenting NAT64 DNS64 usage. And maybe 464 XLAT can be one of the cases, but not the only one.
Well, 464 XLAT should be one configuration that it might be put up in. But in any event, so bring that back, generate discussion on the list, and we'll discuss that in London.
Yeah.
And with that, thank you.
One question I will ask, not just for this document, for all them, I will continue working on all the documents from today and from 2 days ago. I will like to have some co-authors in some of the documents, so it's not just my point of view, but also, so if somebody is interested in cooperating in the documents, please contact me.
As I always say, if you're a newcomer, you just heard the call to help write something.
Thank you.
So one of your documents earlier today, I've actually already posted to the list saying, do we want to adopt this and how do we want to proceed? That one for sure. This document, so bring us back something. The others, I'm not so sure.
We'll see. Okay.
But in any event, that exhausts our agenda. Let me throw out A or B. Does somebody want to hold forth and rant for a while? If not, I'm going to adjourn the meeting. So, yes, thank you. Okay, then I think we stand adjourned.
You filled up the room with words.
I think most of the oxygen left the room.
I have no lunch.
Sorry?
I have no lunch. Yay. I don't have to be in here.